Hello, everybody. Welcome to the LSA, Thursday, the 29th of February. Very nice to see you all. Welcome back to those who join us regularly. I see familiar names every week, so that's very nice to see you again. And welcome to anybody who has joined us for the first time. And hope that today's talk will whet your appetite and you will return again to this, what is turning out to be an incredible series this year, diverse in all ways. And I hope this is, we intend to continue as we have set out so far. Just to remind everybody, last week we heard from Dr. Bola Abisogun from the BIM Academy about really the power and use of digital twins in thinking about how to prioritize diversity in practice and leadership, and promote diversity, I should say, rather prioritize, but certainly an incredible talk that spanned a wide range of topics, but really thinking quite a lot about the use of the digital twin in both an organizational context and for design use, and for collaborative use primarily. And next week, we will hear from Ronan Morris of Right and Right Architects. The title of the talk is Sustainable Architecture in Heritage Settings. So quite different, but no or more less relevant to many of the projects and work that's going on out there, and certainly here at the LSA. But without further ado, I'd like to introduce today's speaker, Kartikeya Rajput from PRP. Kartik is the sustainability lead at PRP, and he will outline the context and guidelines for approved document O. O for overheating. So the title of today's talk is Tackling Overheating in New Homes. Kartik will introduce the principles of thermal modeling, providing invaluable insights into the approach to assess and manage overheating risks in homes. Kartik is an associate director at PRP and a module lead at the University of Westminster's master's program in architecture and environmental design. With over 12 years in industry experience, he's led the environmental design for numerous schemes and delivered some of the most sustainable buildings in the UK and abroad, which is quite a claim, including Sterling Prize-winning Kingston University townhouse. So without further ado, welcome, Kartik. I know you have lots to tell us and talk to us about, so I'd like to hand over to you and just welcome you to the LSA Thursday Talk series.
Perfect. Thank you, Samantha, and welcome to everyone who is joining the session today. I hope you all can hear me well. It's just a quick check to ask. You can. Okay. I've got some introduction slides as well, Samantha, so thank you for introduction, but I'll probably go through them very, very quickly. But to start, I'm going to share my screen first. If someone can just give me a signal that you can see the screen, that would be perfect. Oh, you can. Oh, great. So very quickly on my background, I've got if I can say in more polite manner, I've got a very strong background in terms of environmental modeling. What you're seeing on the screen is different kind of environmental studies that I've carried out in the past and through my journey of environmental design. And this extends from any kind of outdoor analysis to indoor analysis. And it extends in terms of its breadth from human adaptation studies to CFD studies, which probably considered to be the most extensive ones, including the optimization between all of these studies. So I've got two sides to myself. One is professional, the other is academic. So I've been involved, I'm currently working as Associate Director at PRP, but in the past I've been working with consultants, mostly M&E and sustainability design sort of a consultants. And I've also got an academic side where I've done my master's from Architectural Association and currently teaching at Westminster along with having ties with other universities. So I've got two of these sides. More recently, these are some of the examples of the projects that we are carrying out at PRP. So there is a big breadth of work which extends from writing guidances to carrying out post-occupancy evaluation and obviously also undertaking loss of overheating assessments. One final slide about us. All the environmental studies requires a lot more integration in terms of softwares and modeling methods. And an important point in between is the building physics platform, which sits somewhere in the middle. So it's not just about doing a modeling, but it's also about understanding what's the building physics goes behind it, and what are the outcomes of those building physics simulations to lead to some sort of passive design measures on sustainability integration into building. So it's just a prompt on that one. Moving on to today's session, which is around tackling overheating and essentially focusing on part 2. I've divided the content into some sections so that we can go through it. It helps you to understand what we are going through in today's part. So we are going to look at the background into approved document O. There are two methods in approved document O. One is simplified and dynamic. So I wanted to introduce both of them and give you a little bit of a flavor of what is the difference between doing simple calculations against when you go and do something which is more comprehensive and what we call it as thermal modeling. We've also created or in a process of creating our own in-house tool or assessment. So I'll probably show you some very quick images around where it is, and there will be a lot of key messages which are dotted around in the slides, but we'll end with something more simple for you to take away for yourself. So I won't go to start with today's session in more detail. Before we jump on to part 2, the real question is overheating a concern in the UK? There are lots of parts in the globe around the world where it is, and you will be slightly surprised that a decade ago, people were not too much worried in the UK about overheating. And that probably is one of the reasons why we are why we are seeing these new building regulations coming into force. Another reason to this part is that if you think of in terms of temperatures, the last 10 warmest years have been since 20,000, early 20s. So that's a very good a reminder for all of us that UK temperatures are increasing. We've also recorded a temperature of higher than 40 degrees Celsius, which was in 2022. So we have broken that threshold of what's the expected level of maximum expected temperature in the UK would be. Quick points on future. So the future is not going to settle down. It's going to get more hotter. The same is for the UK. And this is expected that there could be a 5-degree temperature difference by increase by 2070. So it's just a small thought that I wanted to leave in everyone's mind when we are looking at this session. There is another aspect to this other than climate change. This brings a lot of risk to buildings and people who are inhabiting those buildings. And essentially, these risks are of two kinds. One is which is a lot more serious in terms of death, and lots of deaths are already being linked to overheating, and this is going to increase. So the number is expected to be higher, and that's why we have to be a lot more careful about this. On the other hand, is also the quality of the property, and at the same time, this could be a defect that can be considered if building does not mitigate overheating. There is also some studies which suggest that already 20% of UK homes are overheating. So there has been a big requirement for us to come up with a regulation, and that's why you are seeing approved document O, which has become part of building regulations now. Another reminder on temperatures are that even when you look at London temperature and compare it against the present and the future, which is next 30 years, there is very significant amount of temperature increase. Along with that, we have solar radiation increase, and there is a lot more fluctuations in wind speeds. So it's not just about temperature, it's also about solar radiation and winds, and more holistically, the entire climate that we have. So a prompt here would be that the UK climate is not the same what it used to be 10 years back or even 20 years back. It's changing, and it's changing very fast. And that probably gives us an indication that our design of the building should also be changing. So that hopefully this sort of statement echoes throughout the session when you look at the other slides. Moving from climate to comfort, which is very important. So if you compare climate with how we feel uh, when we are in that geographic location or within a building, is more important to come to understanding of perception of people and the climate. So here what you're seeing is those factors that like some simple factors: temperature, solar radiation, wind, and humidity. And what are the subcategories of this which affects our comfort? So it's not just one thing which affects the comfort, it's a combination of all those things. More generally, like if you think or if you talk to people and your friends, you will talk about in terms of temperatures, but that's not the entire story. You have to think of global radiations, you have to think of wind speeds, you have to think of what humidity level is, you have to think of mean radiant temperatures and lots of other parameters. So we're not going to go in super detail, but I do want to bring this discussion at the forefront that it's not just temperatures. There are a lot of other factors as well which are involved in achieving thermal comfort. So approved document O is not something new. So when you look at what UK has already been coming up with the guidances, and there have been some good guidances by SIBSI and other, mostly from SIBSI, where there have been, wherever these can be tracked back to early 20s, where there were some principles outlined for designing for natural ventilation. Later on, there was criteria that has been established for doing thermal comfort assessments, which is BSEN 15-2051. From that, we had a technical memorandum from SIBSI, which was around establishing comfort criteria. That got embedded later on into SIBSI Guide A. Then we had SIBSI TM59, and more recently now we have Part O. So we had these guidances, but what we did not had was a building regulation. So if you think of it, that the principles existed, there were some buildings who were doing all of these things, which was requested, but there was no trigger in terms of building regulations. So that has given us a big strength in this context. So Part O essentially relates itself to new residential development. So it's not relating itself to non-residential development, but it extends a little bit into building categories which are related to greater use of people to use as living spaces. So care homes, for example, which might fall into non-residential category, has to undertake the assessment, which is Part O. So this slide gives you a more understanding of that. If the document says new residential buildings, please don't think that it's residential. It's just dwellings and flats. It could also be student accommodations, care homes, and other things. So what we are going to, what Part O brings is not entirely new. It is utilizing the methodologies and methods from SIBSI TM59. So usually when I say it as Part O, I usually say SIBSI TM59 plus Part O, sort of a connotation rather than just saying Part O. So, and it's also a prompt and reminder for all of us that it's not exactly the new. So Part O, you will have, this is an extensive guidance in terms of what needs to be done, but a lot of it also exists in what we call it as secondary and tertiary documents. And TM59 is one of the very primary that secondary document that you need to refer to if you want to understand and go a lot more deeper into what are the principles, what are the physics, what are the criteria that are being used. Part O wouldn't say much on that. It simply refers you to this SIBSI TM59. Essentially, like the new thing, so you might ask, what's the new thing? The new thing is a simplified method, so which I'm calling here as approach 1. And the approach 2 is reflected back to SIBSI TM59 with some sort of additional controls or some sort of additional limits being set against that. So the simplified method is completely new, and the dynamic modeling method is piggybacking on TM59. And if we can think of it, one being as perspective and the other being a simulation method. So what we have done already, because we are also an architectural practice, we have done a test against both, and then we have found out our own interpretation, what should be used where. What we found out is that the simplified method is not detailed enough to capture all the subtleties that a building would include into it, and it is more sort of a high-level assessment. So most of what we are considering at the moment is dynamic thermal modeling. But I will go through this simplified method, and there might be fairly quickly to give you like a little bit of an introduction that what it is. But please, if you ask for it, what we are doing, we are considering dynamic thermal modeling for all our projects. That's the approach that we've taken. So part O, simply in a very simple manner, it talks about two things. One is mitigating overheating and basically limiting the solar gains inside the building during the summers, not winters. And at the same time, it requests for providing enough amount of means of removing the heat, i.e. natural ventilation measures, so that we can make best possible use of passive design. In addition to that, Pato has also come up with some sort of a safety requirements where we have found out situations where, although if the building is making use of passive design measures, it's not following the principles of either secure by design or safety or other things. So the Pato helps in bringing all of these disciplines together. Even in this document, the mechanical cooling is left as a last resort. So if all on your projects, please don't go with mechanical cooling option from the start. You really have to explore passive measures first, and you have to demonstrate that you have undertaken those processes. So simplified method is, to make it simple, what has been done is England has been divided into two categories, which is high risk and moderate risk sort of connotations. And then the next thing is ventilation aspect is being divided into like units which have cross ventilation and single-sided ventilation. And the last one is orientation of the facades. So wherever where the proposed building has bigger orientation of its facade. So if you have these three information, you would be able to make your first step towards doing a quick prescriptive method calculation. So this is not dynamic, it's simply based on hand calcs sort of approach. So there are some codes which defines what is high risk and what is moderate risk. You can find it in the ADU approved document O. And then what you have to do is look for your postcode and just locate your building, and you might be able to understand where it is, whether you are in a high or moderate risk. In terms of cross ventilation, the definition of cross ventilation is something very, very interesting, because if you look at different documents, the cross ventilation means something different. So the idea is I guess is fairly easy for everyone to understand what it is, but in the past or even now, it has not been entirely resolved that what it is and what you would classify as cross ventilation. This is also related to this complexity of the buildings and the unit itself. But it's an important point for all of you to take back today, that actually, if you look at all these building regulations, what does cross ventilation means? And it's a very simple thing. It's not something very complicated. But this is where the complexity lies of the reality that we get stuck with. There is another prompt on cross ventilation. If you look at the new London guidance, where you see another definition of cross ventilation. So moving on to part O is making it very clear that the opposite walls of the units, if they have windows, that is what we would mean cross ventilation. And this assessment is at unit level. This is not at building level. So your building might have windows on two ends of it, north and south facade by an example, but that would not qualify as cross ventilation if the unit itself do not have the opportunity to have this cross ventilation aspect from the two ends of it. So please remember that it is unit level assessment, and it has to be on the opposite ends. Once you have this three things information, then the step is how do we apply these two criterias, which is limiting solar gains and removing excess heat. And to tackle this, the simplified method has capped the maximum glazing areas. So you can't provide more than certain amount of glazing ratios. And they have also capped, uh, not capped, but they have also outlined the minimum amount of ventilation area that is required. So those two things are what you need to achieve when you're doing these sort of hand calculations. So I've tried to simplify the guidance from ADO. So sometimes when you might have looked at it already and might found it a little bit more confusing. Hopefully this diagrams make it a little bit easy for you to understand what does this mean. But if you follow a method of from the top in this diagram, first deciding which location we are, so high risk or moderate risk, and then deciding cross ventilation and single-sided ventilation, then you have got all the percentages that we need to meet required by the criteria. So if you follow that sequence, then it might make it a lot more easy for you to interpret this table. I don't expect you to interpret, but and therefore I've made some simple studies which will help you to understand. But essentially, it is location, single-sided or cross ventilation, and then different orientation of glazing facades. With those things, and for all of these different options, you have to meet different amount of glazing ratios. So very simplistically, like what we have to meet in terms of criterion one, which is for limiting solar gains, we have to comply with maximum glazing area at unit level as well as at living room level. So you have to comply with these glazing ratios against the unit floor area and also against the living room area. So therefore, that's what the G1 and G2 represents in this case. So in addition to that, based on the orientation of the unit, which is the where is the maximum facade area, we also have to provide one of the three, which is either have a glazing with solar control or external shutters or overhangs. So these are the requirements for limiting solar gains. And if you think of it being percentages that you have to meet in terms of glazing ratios, it might make it a lot more sense for you why that table and what it was. In similar manner, in terms of making sure that we have enough sort of openability at a unit level, there are some percentages which are being outlined at unit level, but at this time it's also been outlined at bedroom level. So comparative to the living room, now what you have to do is a bedroom sort of a calculation. And what we have to do is, again, if this is the same order, that where is the location, identify which which building risk category it falls into, and then whether it has cross and single-sided ventilation. And then you have to provide for those percentages that have been outlined in the ADO. All these percentages that you're seeing in the diagrams, you can find in the ADO. So it's just a direct extraction from there. What you would have noticed is that there are some opening percentages against a facade option, which is very, very high. So you can see there is 95% of facade that has been asked to be open. So we've done some case study which will make it easy for you to understand the implication of these calculations. But before we jump into that, an important point or reminder is that these openable areas is not based on just the size of the window. It is something that we use very often in our environmental considerations, call it equivalent free areas, but it might come across a little bit more challenging for you to do these calculations if you are new or you haven't been aware of this. Essentially, these are a lot more detailed calculations which accounts for opening of the windows, type of the windows, angle of the windows, and other things. It's something that we have done very commonly when we do fire vents and smoke vents sort of calculations. Pato has also created a method where you can do these calculations. So you have to do these calculations to come before you arrive to your openable areas. So it's a reminder again that you have to be careful. It's not just the size of the window, but it's a little bit more complex calculation. So for this session, what we have done is we took one of the case examples. This is in London, one of our projects. And what we've done is we've taken a one-bedroom studio in a typical 10-rise apartment block building. We thought that this assessment could have a lot of impact on the standard units that we usually do. And hopefully this would also be a standard unit in terms of the sizing that you might be working on currently. So it's not very different to what current building standards request for in terms of areas and other things. But keep in mind, this is for a flat assessment, not for houses or detached units and other things. So what we did is we took two opposite orientations, east and west, but the unit size is exactly the same. So it's exact mirror of the unit, but we've done study for east and west to understand what's the implication of this requirement is. Then the criteria, remember that that I just showed, we converted them into the areas. So we've done this a whole set of calculations at the background, and we arrived to what are the requirements at the unit level or at living room level, bedroom level, and we've converted these ratios as requested by in the simplified method. And then we converted these areas into percentages as requested in the ADO method. So we did this calculation in the background. The next step for us was to compare what we need to do. So we did now the comparison, and the comparison is on this circles that you see in white background. And probably here I would explain a couple of points, but the two main important things that stood out was when we compared our unit to this sort of requirement, there was we had to comply. We had to reduce the glazing areas, and at the same time we had to increase the ventilation areas. And the reason it is being divided into living and unit level is because this is what the simplified method requests to undertake as an assessment. What you're seeing on the right-hand side is the current facade. So you're looking at the elevations related to that unit in a little bit more detail. So this is what we have currently. And next, we started looking at the impact of these ones. So we started looking at that, okay, if we have to reduce or match this limit, what will happen? So you could see the impact of this living room. It's almost like we have to reduce our glazing to the half. Then moving forward, we had to make more adjustments on unit level. So made our bedroom window slightly smaller. And to accommodate more ventilation in bedroom, we had to change our window sizes as tight. The next thing was at unit level to meet this free area requirement, we have to add a vent. So you would probably see like the amount of changes that this facade is going through to just incorporating these looking like simple guidances or percentages. Then we did more calculation based on equivalent areas, and this is what the facade would look like to comply with this requirement. And essentially, what's happening is that almost everything has to be converted into a vent, and which could have a very detrimental impact into energy aspects and could also have an impact into daylighting. So we did that test as well, and you could see that our daylighting was failing for living room as well, which is another requirement that you have to meet on your projects. So if you start thinking of aligning with energy requirements, daylighting, and overheating, there were some contradictions here. And what we did in summary, we moved very quickly away from it, and we said these are very quick, 4 simple outcomes to put forward. We believe that simple method is not simple, and it requires a lot of calculations. You have to do all those calculations for every kind of unit, which is showing some difference. So there's a whole host of calculations that needs to be done in the background, and you might make lots of mistakes when you're doing these ones as well. Second is that the simplified method had lots of limitations on facade design. So all facades will start looking like very, very similar, which essentially what we don't want to do from an aesthetic point of view. There was a lot of challenges for developers in terms of having different requirements for different orientations. So their standard house types would take a little bit of a hit on that. And the guidance itself says that if you have communal heating, you can't use the method. So we instead of to simplify it to this level, what we thought is the approach for us should be to go full dynamic modeling for all kind of units that we have, and we are going to build in something which is more robust, and not just in terms of environmental qualities, but also in terms of its viability, its aesthetic characters and other things. So moving on to the second, so hopefully this gives you a good idea of introductory idea of simplified method. Then we move to dynamic thermal modeling method. This is where I want to bring more of your focus. And dynamic thermal modeling is something which you can test in a dynamic way, and where the dynamic word means more related to dynamic of the climate that we are subjected to. So in simple terms, every hour of temperature or the simulation that you do, every hour gets accounted, and the effect of every hour changes gets accounted into the results. So I mentioned already that we are using CIBS-ETM59, but there are some additional limits that Prato brings on top of CIBS-ETM59. And we'll go through those limits, what these are. But if you think of that we have made this switch from simplified method to dynamic method, that will be like a good start. So essentially the limits, these are the limits that Pato has placed on TM59. So these are additional things that you have to do. They might sound very complex, but I'll go through in a simple manner. What has been done is that you cannot open the windows when the temperature does not exceed to a certain level. The reason it is being done in this manner is because this has been misused in previous assessments. So people assessments were carried out and with assumptions that windows will be open 10 degrees Celsius or 15 degrees Celsius, which usually is not the case because it's more dependent on occupants. So when occupants feel warmer, then they start opening the window. So they've limited it to be open at certain temperatures. There is also more guidance around what is nighttime and daytime. So those time periods are being classified now. And then there are also some issues around that has been covered around secure by design and safety aspects, which is a very welcome sort of initiative, because we do need to align these different requirements in our design. We can't just say environmental consultant, open the windows, and yet it's not secured. And so occupants would not use it in reality. So before we jump into the dynamic method, what you're seeing is a little bit of a comparison. So imagine what we have is the requirement. This was set by simplified method, which were mostly around minimum areas, free areas, and glazing ratios. And there were some common themes around location, orientation, and ventilation strategy. If you think of a dynamic method, it includes or it undertakes all of the other parameters that can also have greatly influenced the assessment. So for example, it considers more accurate air tightness, thermal mass, opening of internal doors for the benefit of moving airs between one room to another, acoustic ventilation, for example, MVHRs could also be used as a benefit, shutters which are more extensively designed, glazing ratios, fabric performance. So it covers a whole host of uh, items for informing the results. And if I can bring it into the context of building physics, it also covers aspects which are a lot more in terms of factors which are a lot more influential in terms of thermal comfort, both from the outdoor and the indoor factors. So it considers all these building physics factors when it's undertaking when the simulation is being undertaken. So what thermal modeling looks like is something like that. So if you think of it's not a Revit model, but it's an independent thermal model where you've got all the information about different sizes of windows, how they open, orientation, relationship between one space to another, thermal transmittance, all aspects of heat transfers, for example, conduction, convection, radiations. So you're looking at all of these parameters together and churning simulations. So this is the part which becomes very extensive, and you need to be more of an aware of in terms of building physics to control these kind of factors and and features. This is an example of how we do zoning. So it's very important how you connect one space to another, because there's always a heat transfer that happens from one space to another. So it's not just outside against inside sort of discussion where facade becomes the most important. It's also about how the space organization has happened within the unit itself, and how energy moves from one space to another. So a little bit more sneak into what it looks like. So we use architectural drawings to create the 3D model, capture right volumes, orientations, weather data. Then we create our own constructions, which are more accurate in terms of materials and other things. We identify all the openings, the percentages they open, and what you essentially get as an outcome of the results is this sort of a table where you can look at every room and you can assess whether this room has complied with the criteria or not. And there are essentially two criteria which you need to comply with for bedrooms, but living room you just have to comply with one criterion one, which we call it in TM59 as criterion one. But bedroom you have two criteria to comply with to demonstrate a pass. So using this one, you can assess whether the space or a room is failing or passing, and then you can do a lot of iterations, go back and forth, and start improving those kind of things. So with the same example, what we did is, so you saw the extent of that case, the implication that the simplified method had on this unit. So we took it same unit and did the dynamic thermal modeling. But here what we said is that we know that the design already has some good features incorporated, and we are going to check the benefits of that. So those features were like using MVHR, for example, during the summertime as to provide additional ventilation. We had shading which was more specific to orientation. We also looked at the glazing specs, which we can optimize further, the opening areas and the type of the windows, and also the benefits of how we can open and close internal doors to have some sort of a comfort. So we created these 5 examples where case 1 was TM59, case 2 is overheating ADO, which is essentially a cumulative version, TM59 plus ADO. And then we created some further cases which are very relevant to London context, which is dependent on acoustic and non-acoustic environment. Because you might have seen already on your projects that lots of projects that you're building, if they are near to a rail stations or busy roads, you are not being allowed to open those windows. So we thought that we need to build this sort of intelligence into our simulations. So that's what you're seeing as the variation between acoustic and non-acoustic. And we tested those results. So we did lots of iterations, but essentially this is the summary of those iterations where we could make our spaces work. So if you look at exam case 3 and case 5, which is a scenario which is non-acoustic and acoustic environment, we were able to make all of these, this unit in this scenario to work and comply with the requirement. And why we've been able to achieve it is an outcome of looking at multiple factors, not just a few. So even though like the ones which are in simplified methods are either primary factors, no question, but there are also factors which has their own bits to contribute towards achieving comfort. And this is what this study demonstrates. So what we did is we created our own those factors list. So this is not all of that, but we started creating this sort of an optimization, what we call it as levers and optimization parameters. And we started playing with it, saying in what areas we have to have deeper balconies, or in what we do not need to because there is a shading from the context, where we do fixed shading, where we do glazing ratios, where we do glazing spec, and lots of other sort of stuff. And if I can do something very, very quickly, hope this video works and is working for you. But we started converting it into using our dynamic simulation model. We started converting into call it ledger, where you could play with these sort of quickly play with these sort of studies and then change them and look at whether we can comply or not. So this is what we considered as our simplified version of the assessment, but this has a lot more intelligence around dynamic, which is being fed by dynamic thermal modeling and real case examples. So I'm moving a little bit of what are the main strategies to consider. So more on the sides of what we should be doing. So I tried to make it super simple rather than making it complex. But and hopefully this just the titles and the words that I'm going to mention will resonate with all of you and all of your projects. So I tried to make it that very simple. But the most important thing is for us to understand the orientation of the building. That's the key for us to unlock these special design measures. So sometimes it's the site itself which gives you challenges, but it's critical for us to understand the orientations. I can't stress this more how important it is. And if you think of environmental, it's almost like the environmental considerations are like a sequence sort of thing. If you make a first bad move, then you have to do a lot more good moves to get that bad move offset it. But if you make a good first move, then everything falls in place sort of thing. The next will be easier, and another will be easier, and another will be easier sort of thing. So orientation is the most important. You could also get a lot of benefits of if you are doing a development which has blocks, you could get lots of benefit of playing with the heights and how do you place these blocks in the context of each other to add those benefits. These are not struggles, these are just intelligence that you can build into your projects where the building is more than one block. There is also benefits from developing surrounding area, which could add some positive improvements. We call it as a microclimate, creating a positive microclimate. You might have heard lots of publications now coming into it, but essentially what it means is make best use of vegetation, ground surfaces, lighter color finishes, surface reflectances, which can create a positive environment around your building. So essentially what it means is that the temperature, if you are sitting in your flat right now, would not be the same where the other person listening to this presentation would be, even though we all are in London. So it's not one constant temperature. It keeps changing, and it is very much dependent on what is around it. And if I give you another example, imagine you walk around Hyde Park right now or in summers, and then you come to the main road, which is adjacent to Hyde Park. You can feel that difference very clearly. You can measure that difference too. And that difference could be in the scale of 5 degrees Celsius or plus. So this is what we also call as urban heat island effect. But within the urban heat island effect, there are lots of uh, temperature variations that happens. So we need to make it more positive for our site, and then you can take the benefit of that. There is another important, if you are in London context, another important thing to consider is identify all the risk that you can have. So for example, restrictions related to opening windows or not, whether there is a busy road or train tracks, so that you can build those strategies early on. Undertake facade radiation studies. This is not very complex example, but you should be able to run some quick calculations to see what's happening on different facades. And then based on those different facades, you can design them differently. They don't need to look very different. They all just need to respond to different orientation. That's the main key point. And an example of that is if you look at these two simple boxes, one is facing more on south and the other one has got more orientation. Oh, sorry, I made a mistake here. But no. But if you think of as a orientation, which is in gray of the building, and then if you add some simple features, which is horizontal and vertical shading, what you can see in red is how much of sun that you can shade during different seasons and different time of the year. And these are simple benefits that you can get. So for example, in the one where you have horizontal shading, you could see that peak summertime, you've been able to shade for some of the hours. So these are very simple sun path studies that you can undertake and to make an estimate where you want to shade and not. But hopefully the diagram shows the difference that they can have. So for example, in this, although the building is exactly the same, if you incorporate a vertical shade, aesthetic reason, it might not help at all with shading, providing shading to the window during the early midday sort of time throughout the year. And in the other one, you might get it during the summers, but in winters, you might be able to get good sun inside the space. So these are super, super simple. And then you can make it, you can extend them to like the way you like. So you can, once you have identified whether it's horizontal and vertical, then you can make it more fun, then you can make it more good, better, and you can start matching your aesthetics with it. I've just added vegetation on windows. They might find like cheeky, but I've seen examples of it and I love them. And then I've seen them in London. So like green walls, and can this something like this can happen? Why not? And why should not? If the climate is changing, why can't we perceive that sort of a step? So this is just a food for thought. Another side is I've made it bigger, but adaptability of our facade is going to be the key going forward. And hopefully this image gives that impression. And this is where I always say in all my talks that our climate is changing. And there is lots of reference of it in Europe, where we have been in climates where you have seen summers, you have winters, and you would identify that the buildings has lots of adaptability to it. And currently, I'm seeing less of it in our housing developments, but in future, there is no reason for us to think that wire facades are not going to be adaptable, because they have to work for summers. They might also have to work harder for winters. So therefore, adaptability is a key thing for us to think of when we do our facade design. And I would also extend it to adaptability of uses of space, because you can move it around. And that's what we've learned from vernacular architectures all across the globe, all types of civilizations, that we have always been very adaptive rather than thinking of one space being giving the solutions for all. There are some quick examples on, given that acoustic is becoming almost like a challenging position. So you want to open the windows, but acoustic study will say no. So I thought that just have this one slide for you to tell that there are lots of ways to tackle it. Different tilt of windows will have different impact on acoustic. You can different specification of glazing itself will have. Then you have an opportunities of acoustic vents, and there are also studies and examples where you have attenuated windows. You can do detailing. So these are examples from various projects. You can do detailing where we can attenuate noise as well as bring the air in. And of course, they can do something to balconies and other features around the openings to get some further attenuation. But this could also, it's not just again one thing. You could apply multiple of these factors to ensure that you get better attenuation. In addition to that, so there are I've simplified it to 6 things which ADO requests us to be considerate of. One is noise at nighttime. So therefore, please undertake acoustic or noise considerations or assessments early on. The pollution is also is a challenging position. We've been saying that the air quality is not great, so you can't open the windows. But this is a question maybe for discussion, where what do you want to do? You want to seal the buildings, or you want to solve the problem which is related to solution? I would say the second one, or to pollution. I would say the second one. But it's absolutely important for us to have this openability built in, and not just say that is air quality because of which you can't open the windows at all. Security is an issue to consider. Protection from falling is another very important issue for us to consider in addition to protection from entrapments, where we've got kids, and usually young kids always likes to reach out and look out sort of thing. So it's very, very important. And the last thing I would say is home user guides. We also need to provide home user guides going forward, where people who are buying and living in these new sort of units and houses, they understand when they need to open their windows and to close them. It might sound very cheesy to say this, because we all know how to open and close the windows sort of thing. But we haven't actually had this experience once you have an MVHR, which is also helping you at the same time. So, and can you actually have open the windows early on and then get benefit of some sort of a purge? So I'd still think that there is there's a good education part that we need to integrate even with passive design measures for our users. Key messages. So I'm almost wrapping up on the presentation, but these are some of the key messages for all of you. So projects will require, and I'll probably go through them, and hopefully it'll be easy as well to understand. But we are seeing that most of the projects will require dynamic thermal modeling, and because of the regulatory compliance. And what we think is that the dynamic thermal modeling will be the way to go forward. Given that we have all this, if I can say, science behind with us to help us, I think we are in an age where we have to use these tools to incorporate all that intelligence that we want to, especially when we are we are challenged not just by one factor, but many factors. And in this scenario, we are challenged by overheating, at the same time air quality, at the same time noise, so which we never existed before in the past, or it was easy to handle. So our friend is science and technology. Then the buildings needs to have a combination of strategies. It can't be just one. So you can't just say, I've done shading and that works. No, you have to incorporate good ventilation measures. You have to have good layouts. You have to have uh, uh, understanding of how you lock your space together. That's important. Compliance with TM59 going forward is going to be challenging. And when you start looking at future climate, it's going to be more challenging. There are requirements for noise pollution, safety, and security. Mentioned it already. So please be mindful of those ones. There is a good benefit for us to combine our systems. So instead of looking at MVHR just for use for winter time, can it also be used for summer times, provide additional ventilation? Could be another thing to explore. And there are noise criteria related to nighttime for bedrooms, so watch out for those ones, because what we are seeing is lots of consultants saying bedrooms are the ones which are overheating, not living rooms. It's not the scenario. It's just because of the amount of noise. You can't open the windows, which gives us more challenge. This is probably my last slide or second last slide to wrap up things. And this slide is what does it mean on ground? So, and there are lots of things that you're seeing here, but I've tried to make it simple by saying that please undertake your surveys before you start doing the design. It's very important. If you're building next to a very busy and very acoustic challenging site already, you have started on a step which is on a back. So please undertake all of these surveys. Please make sure that these surveys are done comprehensively. If they are not being done comprehensively, you might end up in a trap where because of some simplistic or onerous requirements, you might not be able to develop new steps. Master planning is very, very important. I mentioned it already, but you also have to link it with how you design your spaces and VHR systems, and also in relation to design of your facades. There are some things for building levels. We have to be considerate on the cost itself. So if you are not going passive design measure way, you are including mechanical cooling, which could be a lot more expensive. And there are again some conflicts. Once you go in mechanical cooling way, there could be more challenges in terms of meeting energy requirements. The facade design has to be done more holistically, and it has to be looked into a lot more detail going forward. So I would the end here.
Thank you very much, Kartik. That was just an incredible amount of information to absorb and to sort of start to process, really, but an incredibly helpful guide, I would say, to everybody for how to sort of think about the tools that we have to help us now, and two, to think about how to apply them, and apply to use that data really in ever more effective and I would say beautiful ways in designing our buildings and thinking about architecturally. So thank you so much. We have all of 4 minutes left. So we'd feared this might happen, but mostly it was important to really get through the full extent of the talk. So I'm going to I have a few questions here, but I'm going to probably trim some down because I think one or two have pretty quick answers. One is really around softwares, and there is one question that is specifically in relation to a master's thesis. If you wanted to carry out environmental assessments on a thesis project, or sort of essentially something that's still on paper and maybe in model form, what would be your go-to softwares, websites, quick strategies?
So I wouldn't say X is better than the Y, but I would definitely suggest that in terms of softwares, it's really very, very important for us to evaluate rather than just do qualitative advising. So and when we say evaluate, you can literally get to like very deep end of it. You can say what is going to be the temperature of a room on 29th of February, which is today, at 2 p.m. For my room X. So you can get to that level, and you could also extend it to which year it would be. So you can say let's say in 2025, sort of a thing. So, but Samantha, I would say is that definitely thermal modeling softwares are the good ones to use. You have to wrap it up along with something daylighting softwares too. So usually not my best, but generally that we end up using is daylighting softwares along with the thermal simulation software in tandem to undertake some of these studies. I would, if some of the students are very more interested, then I would also include CFD assessments on top. But the essential would be thermal modeling softwares. There are two softwares which are very, very common, TAS and IES in the industry. There is another one which is more simple. We call it Climate Studio, which kind of host different studies together. And there are some open source softwares as well, which is a combination of a Grasshopper, Ladybug, and Honeybee, which you can use.
Great. Thank you. That's really helpful. And a good pointer. We can definitely expand on that. I'm sure everyone get everyone going. There is a question about I think probably what I will go to, because I'm interested in this, particularly the sort of wider scope. Compared to international projects and standards, how does the UK compare? Is the guidance stricter or in line with other countries? Do you have a sense of
easy one to answer, because you've not said which country, so that's why it's easy. I would say UK regulations are stricter compared to a lot of countries, majority of countries, I would say, purely because we are seeing some countries which hasn't come up to that level. I wouldn't consider that UK is the strictest in regulations. So there are definitely some developed nations which are ahead, but this discussion about whether we are ahead or not in terms of environmental could also be broken down into different aspects. So, for example, materials and in embodied carbon, we've seen France being a lot more ahead. In those kind of discussions, there could also be net zero. There are some countries which are ahead of the UK. But I would place UK in a very good position in terms of where we are. You would see that future home standards coming into place. So there is a lot of good guidance coming into place, which will make mandatory for these assessments to be carried out across the board. So, and there are lots of good institutions which are helping with it. So, for example, UKGBC is doing a brilliant job as well. So it's not just the government, so it's a lot more put from very robust institutions that we've got in the UK, which is helping us going towards it. Sometimes governments could go different ways, so we've seen a little bit of a step back in our targets. But generally, what I tend to feel is this is all going to go forward. We cannot take a step back on climate issues. Europe, you might have seen it that Europe had just passed one legislation. EU had just passed legislation very recently about regenerating biodiversity and restoring nature. So like I'm slightly not so happy, if I can say, very at this moment, because we've just seen that they have passed it and UK might not be
Yeah.
part of it, EU. But I'm confident with UK regulations, and I'm confident with the institutions helping with it for us to be ahead.
Yeah, well, let's hope so. Yeah, for sure.
So,
Thank you
so
very, thank
Samantha,
mm,
sorry to mention, but I'm happy to stay for a couple of more minutes if there are questions. Just to
You're
mention.
very kind. Thank you. Well, I will, that's very generous of you. I'm also conscious that some may need to get back to work. Their lunch hour might be up. There was one more question which I think I can probably answer, because I definitely spotted it in your presentation, which is about how do you find out the location of your, whether you're in a high risk or moderate risk area. And that was definitely, it's in zero, isn't it? There's a mechanism through that references you to the area that you're in. So I
Correct.
hope I'm right on that one.
Yes.
Yeah, very good. And I just think, I suppose my final comment, really, it's a sort of more a comment than a question in a way, but I think it's so fantastic and relevant also, particularly for students of architecture, thinking about their thesis project, the use of this work in relation to also looking at vernacular examples, because what seems to me is many of the design solutions are pointing to mechanisms that we know exist and are out there, and to think about but often in very different parts of the world
Yes.
so there's this sort of cultural question about what we're used to seeing on our buildings, and then perhaps starting to embrace other ways of coming up with design solutions that we might not have thought of before.
You're so right about this, Samantha. In fact, this is a global thing. Like we've seen such good vernacular examples all across the world. And it almost seems like if someone does an extensive study on it, that we built a learning, and we have unlearned it for a period of time. And now this is a moment for us to learn it again, sort of a process. And vernacular examples have been the vernacular elements in the buildings have been one of those things.
Mm,
But and that's why adaptability, like all vernacular examples were adaptive
mm,
and adaptive to the climate,
yeah,
which we don't see much in current time. So like all of for it, yes, and we probably have to go back to our buildings and see like how they performed in that time.
yeah, great. Thank you so much. Kartik, I'm going to wrap it up here. It's 3 minutes past 2, so I don't want to get into trouble for people not getting back to what they're supposed to be doing for the rest of the day. Thank you so much. That was an incredibly interesting hour, and I hope you'll come and visit us at the LSA sometime soon.
For sure,
Um,
yes.
Thank you, audience, for joining us, and look forward to seeing you all next week for Ronan Morris.